No, yeah, that's fantastic. Yeah, that's you can see the potential within that. Good. Okay, well, we'll come back probably with more questions at the end. If we can set up now, move over to Meinrat.
Yeah,
That's my program.
Andy, yeah. Let me find him. Let me go to gallery. Here it is.
Jip, starting up now. So Meinrat and Andreae will be talking about iconography and chronology of rock art at selected sites in northern Arabia. Are you able to share your screen? Brilliant. Please take it away.
Yeah, hello. And first of all, I want to thank you for inviting me, and thank you for attending this meeting and listening to me. My name is Meinrat Andreae, going by Andy. And my presentation will be about our attempt to develop a technique to date rock art, specifically petroglyphs, using X-ray fluorescent, handheld X-ray fluorescent. And you see me sitting there actually at a rock art site and deploying my instrument. So let me see. Well, my pictures don't seem to be moving here. Now it goes. All right. So basically, the idea is that petroglyphs are created by removing rock varnish, and that creates a new surface on which this rock varnish, which is a coating, I'll get to that in a little bit more detail in a moment, a coating on rocks is, that's particularly frequent in deserts. And so after the artist removed the varnish to create the image, varnish formation starts again, and it takes something of the order of 10,000 years, typically, varies a bit with kinds of rocks and the climate, about 10,000 years typically for the varnish to completely redevelop and match the surrounding intact varnish. So this varnish, it consists of a mixture of manganese and iron oxide oxides in which dust particles are embedded. And manganese is really the diagnostic element here. And so if we can measure the manganese, we basically have a measure for the amount of varnish that's deposited. And the nice thing is that manganese can be easily and non-destructively detected and measured by handheld X-ray fluorescence instruments. And so if we have a way to calibrate the rate at which the manganese redeposits on this petroglyph surface, then we can actually determine the age of the rock art simply by measuring the amount that has redeposited. So a quick look at how does varnish form. Well, it starts out by dust depositing from the air onto the rock surface, and this dust contains manganese in a relatively soluble form called manganese 2. And what happens then is when air oxidizes the manganese 2 to manganese 4, it becomes very insoluble, and it becomes also essentially black or very dark brown. So this then gives us the transition of dust, dust deposited from the air into this crust. And one has to be careful, however, because not every black or brown crust that we find on rocks is actually proper aerially deposited varnish. There is a type of coating that forms as a crack fill in rocks from solution circulating underground, and obviously that has no relationship to the exposure age of the surface. And there's also water streaks that form when manganese deposits from water that runs off the top of rocks. And again, that wouldn't have to have the same formation rate as this aerially deposited varnish. So we have to be very careful when we make analyses to look at the right kind of varnish and examine the surfaces and make sure that we're looking actually at proper aerially deposited varnish. So how is it done? Well, very simply, there's this instrument which looks a little bit like, well, kind of an overblown hairdryer, a bit heavier, so your arm gets kind of tired after a long day of doing this. But it's a measurement that can be done in situ, so there's no need to remove a sample, and it's non-destructive. And we calibrate it with powder standards that are typically used for rock analysis. And when we want to measure the surface density, the thickness, or the amount of varnish deposit, We also have another calibration technique that gives us what we call the surface density, the amount of manganese in microgram per square centimeter, by actually having sampled varnish somewhere else and dissolved it off and then measured the manganese in the varnish by an independent technique. And from that, we can calculate this surface density. Now, the problem, of course, is to calibrate this technique. And so to do that, we need to develop a calibration curve that's based on making measurements of surfaces of a known age. And as we all know, there are very few images, very few kinds of rock art that have a known age. And that's the problem that we start out with, of course, because that's what we want to determine. But there are some things that help. The best calibration surface is actually a dated inscription where somebody created a piece of rock art in the form actually of writing that bears a date on it. And there are a few examples of these in Lianitic, Datanitic inscriptions, or old Arabic inscriptions. Unfortunately, those only get us to something like about 2,000 years or so before the present. There are other options like the Hegra tombs, where there are large surfaces that have been exposed for about 2,000 years, and that can help us. There are ancient Arabian inscriptions. They're more common than these dated inscriptions, but the ages are, of course, much less precise. But we can also use ecological constraints. We know that cattle were frequent in the Arabian humid period. And so if we have images of cattle, we know that they're probably more than 5,000 years old. Camels show up afterwards. So again, as also Maria demonstrated, the number of camel images, especially domesticated camel images, increases sharply after the onset of the dry climate in Arabia. And we have depictions of particular artifacts, for instance, horses, particular kinds of swords, rifles, and so on, that also give us indications of the age of a surface. And so by combining all this, we can then develop for a particular region, a particular site, a rate at which varnish redeposits based on these sort of known characteristics, and then extrapolate that calibration curve to images of unknown age. And so in the following, I'll give you some examples where we look at particular imagery. Maria has already discussed much of the iconography of this rock art in Arabia, and then look at the dates that we get using the PXRF technique. And of course, one thing that we have to remember is that this is not like carbon-14, where you get very precise ages, but it only gives you rather approximate ages with an error typically, or an uncertainty typically, of the order of plus minus 30%. So here is some samples that we use for calibration. Inscriptions, for instance, late Sabaik in the southern Arabia, then a more recent images done with Old Arabic, Al-Ula, with an actually dated inscription, the famous Zuhair inscription. The Kilwa Hismaic inscriptions indicate we're in this mixed picture with humans, animals, and then letters that we could use for calibration. And finally, on the bottom left, you see a tomb surface at Hegra. And at first, when you look at it, it seems like there's no varnish on it, but actually looking at the bullet holes that are on this surface, you see that, in fact, a significant amount of varnish has already deposited on these surfaces, and they were actually quite helpful in starting to develop a deposition rate for this area at Al-Ula, which we started to look at in this last fall. So this is just another illustration of what I mentioned before, and the picture that I modified from Maria Monin's paper that shows the time sequence of the iconography in Arabia with wild camels, cattle, on wild camels and wild oxen on the left, and then going towards somewhat younger images, these Neolithic domesticated cattle, and then moving on into the Bronze Age with depictions of particular kinds of weapons, and into the Iron Age with equestrians and spears. So that gives us a timeline that we can use for calibration. And then already here the inscriptions that I mentioned before. Now, where have we been doing this work? Well, all over northern Arabia now, and going from Kilwa near the border of Jordan to the Sakaka camel site, which Maria discussed already. Then sites here at Higran al-Ula, Juba, Shuwaimis, Jabal Yatib, and Muzaira, close to Riyadh. And you see that basically all these follow this sort of reddish belt, which shows the presence of sandstone. And sandstone turns out to be the preferred surface, both for rock carvers and also for our measurements, because sandstone is a very good surface for varnish formation. So now looking at some examples, here is Shuwaimis, where we have wild asses and hunting dogs. And for those animals, which are characteristic of the Neolithic hunting period, we have found ages that are of the order of about 7,000 years before present, and consistent with the iconographic and archaeologic evidence. This is an example from Kilwa, where we have an aurochs, a wild bos species. We see the head here of the animal, the horns, and the legs here, the back. And you see that this is actually an example of a petroglyph that has varnished is almost fully back to the intact varnish on the surrounding areas, and not quite actually fully revarnished. When we take the measurements, visually it looks like it would be, and that yielded an age of about 7,500 years before present. This was an interesting example of an application at the camel site that Maria discussed. And here you see the head of a probably something like a wild ass, an equine animal, and the eyes are here. And this allowed us to actually demonstrate that these three-dimensional images were actually created in the Neolithic period with an age estimate of the order of also 7,000, around 7,000 years. Now, as we shift into the Neolithic and sort of borderline Chalcolithic cattle herding period, we start to see animals that have these sort of longhorn, looking almost like a Texas longhorn horns. They often have patterned bodies, which tend to reflect the patterned coats that we see on many kinds of domestic cattle. This kind of animal dominates in the sort of, as I say, late Neolithic, but it disappears essentially completely at about 5,000 years BP, at coinciding with the end of the humid period and the onset of the dry phase of climate in Arabia. We see also, and that's sort of a typical thing that we see on essentially all rock art panels, that there are figures around which are later additions, and including like these, we'll zoom here probably, these more recent, well, probably an ibex. And so rock art images tend to be palimpsests, compositions of images of various age. And one of the nice way our technique can be deployed is to look at both the different ages on the given rock art panel, and also in many cases we can identify reworking in particular parts of rock art images at more recent dates. So this is an example from Buzaira near Riyadh, with an age just near the end of the cattle herding period. These Bronze Age images here give us an example of how we can use particular images of weapons here, such as these pommel daggers. And these images, it looks like this guy actually sort of is a predecessor of a Tesla image here, a Tesla symbol. And he also has one of these pommel daggers. Those are typical of weapons that were used in the Bronze Age, and consistent with that age based on the weaponry. We get ages of about 2,500 years before present on these images. More recent then are Bronze Age to Iron Age camels, which are very abundant in almost all of North Arabia, with peaking in their frequency at about 2,000 years before present. Examples here are camels from Shuwaimis that are dominating many of the panels of that site in all sizes, but also with different ages, such as this one, which is of a more recent age with a rider on the camel, and then these typical triangular shaped bodies of camels with sort of these typical ages of about 2 kiloyears. And on the other hand, we then again see younger examples, and this is an example here from Juba, which is dated at about 1.3 kiloyears. And another example here from Kilwa with a rather characteristic style here, the triangular back and this raised tail, and then again, an age of about the same period. We already discussed the Christian period earlier and the crosses that we find. And here's an example from Kilwa, a cross that we dated at about 1.4 kiloyears before present. And that is found adjacent to a monastery site. And the monastery has a very famous lintel here, which bears an inscription. And this inscription has been interpreted by Hoyland with actually an early Christian group, but may have been one of these nomadic tribes that actually converted to Christianity at about epigraphically dated to about 1.3 kiloyears, which then agrees quite well with the date that we got by our PXRF technique from the cross on the hill that sort of faces this monastery. It turns out that this area here showed almost no varnish redevelopment, which may have had to do with the fact that this rock was, for one, partially buried, and also it may have been inside the actual monastery building and thus not exposed to deposition of varnish from the dust, from the conversion of dust. Moving on to the Islamic period, here's some examples from Kilba again, a gentleman holding what looks like a musket, riding on a horse, and then from Kilba, which we get about 250 years before present, and image from Hima with also riders with curved swords, dated by our technique to about 1,000 years before present. And here an image from near Al-Ula, which shows an interesting combination of riders on horses, again, curved swords, spears. And this fellow here appears to be holding a musket, and he's sort of pictured sideways. And interesting enough, there is also a bunch of canids associated here, which seem to be surrounding an Aliyah-like figure, which is a bit puzzling. But at any rate, this shows us that the technique is quite applicable to imagery that's as young as a few hundred years. And for very recent material like graffiti carved in the last few decades, we get consistently ages of essentially 0 years. So to summarize, rock art in Arabia and anywhere else for that matter, we also do quite a bit of work in Western United States, reflects the human ways of life. It shows their hunting activities, herding activities. It reflects trade, warfare, weaponry, religious activities, and it also depicts climate and ecological change throughout the Holocene. And the Holocene is basically the time for which this technique is applicable, since, as I mentioned before, it takes about the length of the Holocene for varnish to fully develop and reach a sort of a steady state, a plateau on desert, on arid type climate rocks. PXRF is a rapid and non-destructive in situ techniques. It allows to take a very large number of measurements, which is important because there's significant variability, and having a lot of measurements allows us to reduce the statistical error in these measurements. We can calibrate by measurements on rock surfaces of known age, or at least bracketed age, bracketed by ecological and technological transitions, so that we have an overall age uncertainty of something like plus minus 30%. This can be narrowed if we have a lot of measurements, so it's more suitable really to determine the age of an ensemble of similar or equivalent images. And it can be also narrowed if we have good calibration surfaces, but in general, the error bars that we use are of the order of something like 30%. So the rate of regrowth is variable at a small scale. That's that statistical error that I mentioned, but it becomes actually surprisingly consistent between sites and even between continents. And I guess what that does is reflect simply that we are looking at a geochemical process which is basically occurring wherever an equivalent climate and substrate exists, regardless of where we are in the world. We, as I've demonstrated before, the results that we're getting are generally in good agreement with the archaeological evidence. And for a final word, there are a large number of pitfalls and caveats which must be kept in mind whenever we do this sort of work. And that would be a whole other lecture, probably longer than 20 minutes, to discuss all these things. Don't go out and buy one of these PXRFs and go and run out into the wilderness and start to make measurements and publish dates until you are quite familiar with all these pitfalls and caveats, which you have to be aware of when you're analyzing your results. So thank you very much for your attention. And just to conclude, a picture with some of my colleagues that have been collaborating with me, and thanking them and the many other colleagues that have cooperated with me over the years doing this work, and to the Max Planck Society and King Saud University for funding that has made this work possible. Thank you.